Welcome to lecture 3 on control system engineering crash course time response analysis. I am Vice SRAVAN Kumar, having 7 plus years of experience and mentored more than 5k students for GATE and engineering services and cracked GATE. Before getting into the subject today, let me discuss how to install Unacademy Learning app. In Play Store, type Unacademy Learning app
all aware of the vast opportunity.
and step 2 is you'll get something like install and you need to install that. यहाँ पे क्लिक करो. उसके बाद में step 3, if you're opting for GATE and engineering services, then click on this, and step 4, click on this plus sign and get this subscription. Click on this subscription. उसके बाद में you'll have plus and iconic रहेगा यहाँ पे. You'll get a dedicated mentor for your preparation in iconic registration, and you can use my code as YSK10 to get maximum discount of 10% for your plus or iconic subscriptions. And there are many payment options. You can use your debit or credit card, EMIs, UPIs, or wallets, or net banking in order to make the payments. These are the different ways of making your payments, and you'll be subscribed to the Unacademy. And let me tell you what we are learning today. Today, I'll be discussing the signal flow graph as well as the time response analysis of first and second order systems, in brief, being a crash course. Good evening, sir. Good evening, Soumya. Ramchandra Kumar, good evening. How are you? Let's see a signal flow graph क्या होता है. Let's see what is a signal flow graph. Now, this signal flow graph is a technique in order to determine the transfer function easily. You can determine the transfer function of a system very easily by using signal flow graph. This was proposed by S.J. Mason. So we call it as Mason's gain formula बोलते हैं इसको. And this is given by transfer function T is equal to 1 by delta summation Pk delta K. And you need to know, Shrikant. Good evening, Shrikant. We are discussing about signal flow graph. So Mason's gain formula is T is equal to 1 by delta sigma Pk delta K. You need to know what are these things. K is number of forward paths. I'll tell you what are these forward paths. P is forward path gain, or it is a product of the gains in the forward path. Delta, let me tell you what is delta K. It is a delta for that K forward path. And I'll tell you what is delta in this. Delta is given as 1 minus sum of the loop gains and plus sum of gain products of two non-touching loops taken at a time minus sum of gain products of three non-touching loops taken at a time plus and so on. This will be the delta. So you need to know some of the things here. One is what is forward path, what is loop gain, what are non-touching loops. Then you will be easily able to find the transfer function of a given signal flow graph. Let me tell you, a signal flow graph has some nodes which are connected by some branches. It is a graphical or the pictorial representation of a given system. Now, forward path is, let's say you have this graph with you, and let us call this as G1, this as gain G2, this as gain G3. Let us give some numbers to this: 1, 2, 3, 4 nodes. Now, let me take it in this way. So, this is 1, and let us call this gain as G4. Now, what is forward path is? It is the path which starts at the first or the input node and ends at the output node without traveling any node twice. That means you can reach from 1 to 4 either traveling from 1 to 2 and 2 to 3 and 3 to 4. This is one possibility. The other possibility is you can travel from 1 to 2, 2 to 4 directly because you have a path. You must be very much careful about this arrow. If at all this arrow is not in the forward direction, let us say it's in the backward direction like this. Now you cannot take this second 1 to 4 as the forward path. Rather, this 2, 3, 4 and 2. If you can see the arrow marks, it is from 2 to 3, then 3 to 4, then 4 to 2. So this will become a loop. So you must have understood what is a forward path. It is a path which starts at the input node and ends at the output node without traversing any node twice. Kartikeya, good morning, good evening. And Vasanta, yes, both for ECE, electrical and instrumentation, for all the three branches, control system engineering is one of the important topics, as you know. So it is very useful for ECE as well as electrical as well as instrumentation students. It's a crash course. You can get maximum out of it. All this 5 chapters generally. The control system is divided into 5. That is covered in these lectures. You can check out my playlist. Once the complete crash course is completed, you'll be in a position to attempt your external examinations, university examinations, and score good marks. So we were discussing फॉरवर्ड पाथ के बारे में डिस्कस कर रहे थे. फॉरवर्ड पाथ या फर्स्ट नोड इनपुट नोड का स्टार्ट होके आउटपुट नोड तक जाने का है, एंड दैट इज you should not travel any node twice, and you should also be very much careful about this arrow marks. And let me take this as 2 3 4 2 was a loop, right? So this is a loop. What is that loop? Two, 3, 4 and 2 was a loop. If you see, I'll just take this to the next slide. Yeah, now if you observe this 2, 3, 4 and 2 was a loop. What is a loop? A loop is a path which starts and ends at the same node. What is the node it is starting at? It is starting at this node 2 and it is ending at this node 2. That means you can observe these arrow marks. It is going something like this. You can draw that. It is 2, 3, 4 and coming back to 2. This is G2, this is G3, this is G4. Now what is loop gain is, it is a product of all these, it is a product of all these G2, G3, G4. It is G2, G3 and G4. This is a loop gain. So we have seen forward path and a loop gain. Then we'll see non-touching loop examples. Non-touching loops, Srinivas Naik, good evening. Jyoti, good evening. So you need to know what is non-touching loop now. Now let's see what is a non-touching loop. Let us consider one graph, one signal flow graph that is given something like this, and let there be a loop like this, and that let there is another loop like this. This is the other loop. Let us call this as G1. The gain is G2 here. This is G3. Let us call this as H1, and this as G4, and this as H2, and this as G5. And we'll mark these nodes 1, 2, 3, 4, 5, and 6. Now let us say there is another loop like this. Let us call this as H3. Now in total, if you write what are the loops, how many loops are there in this given graph? So if you see 1 to 2, 2 to 3, and 3 to 1 is the loop 1, and let's draw that loop. This is one loop, and we can mark them. The other loop is you are moving from 2 to 3, 3 to 4, and 4 to 2. This is loop 2. You can see this loop here. This is the loop. So you're moving from 2 to 3, 3 to 4, and coming back to 2. Shiva, good evening. Nagesh, good evening. So this is G2, and this is G3, and this is H1. Most probably it will be given as minus H1 if it is negative feedback. So this is a loop 2, and let us write loop 3. There is another loop which is starting at 5 and ending at 5. So this is a self loop, we'll call it as. So this is loop 3. So this is a self loop. Now these are individual loops. These are called as individual loops. Now what are non-touching loops then? Out of these, what are non-touching loops is, now let us write here non-touching loops. What are non-touching loops? Loops that do not contain any common node are called as non-touching loops. Now let us compare the first loop with the second loop. Compare these two. Is there a common node? These are node numbers, right? 1 to 2, 2 to 3, 3 to 1, and 2 to 3, 3 to 4, 4 to 2. If you observe, there is a common node 2, and there is also a common node 3. So these two, loop 1 and loop 2, are touching loops. They are not non-touching loops. And if you compare 1 with 3, see, the first loop has 1, 2, 3, and 1, whereas the loop 3 has 5. So we can say loop 1 and loop 3 are non-touching loops. I'll call them as L1 and L3 is one combination of non-touching loops. Now I can also compare the second loop and third loop. Even if you observe in loop 2 or loop 3, अगर देखें तो इसमें यहाँ पे loop 2 में क्या है 2, 3, 4, 2 है, और loop 3 में क्या है 5 है नोड. क्या कुछ नोड कॉमन है इन दोनों में? नो, देर इज नो लूप, नो नोड कॉमन टू दिस. सो क्या लिख सकते हैं यहाँ पे? लूप 2 एंड लूप 3 आर ऑल्सो नॉन टचिंग लूप्स. सो दिस इज हाउ यू विल राइट what are touching and non-touching loops. First you need to know non-touching loops के बारे में पता होना चाहिए. From that you'll be able to find individual loops और non-touching loops दोनों भी पता होना चाहिए. From that you'll be able to find the value of delta. Hope this is clear for all. So we have seen what is forward path gain, second loop gain, और यहाँ पे क्या देखे हमें? यहाँ पे इंडिविजुअल लूप्स के बारे में देखे थे. And then we have seen what are non-touching loops. So these three are very important in order to determine the transfer function of a given system by using signal flow graph or Mason's gain formula. So with this knowledge, let us try to solve some question. If you see this question, for the signal flow graph shown, derive the gain, this is x5 actually, by x1, using mass and gain formula. This is one of the question asked in the university examinations. So I'll write this. This is x5 output and this is x1. So we already know transfer function is equal to output by input. So Laplace transform of output by Laplace transform of input, and this is the signal flow graph that is given. From this, the first step is, in your examinations you should always write the first step because it is already given as Mason's gain formula. तो पहले क्या लिखना पड़ेगा यहाँ पे, सब लोग Mason's gain formula लिखना. What is Mason's gain formula? T or T of S transfer function is equal to 1 by delta summation pk delta k. 1 by delta. Nice teaching, sir. Thank you, Nagesh. So that is the first step कि Mason's gain formula लिखना. उसके बाद में आपको पता है what are pk delta k and what is delta. So first you need to write this. And the second step would be to find how many number of forward paths are there. कितने forward paths है इसमें. आप देके बोलना कि कितने forward paths है इसमें. What is a forward path? You'll start at the first node and end at the last node. I want some of you to tell me if you have understood how many number of forward paths are there in this. So let me tell you the number of forward paths. If you see, you're starting at this point, moving to this, and you can directly go to x3 as well, then to x4, then to x5. This is one forward path. So let us write that. So path 1, forward path 1. What is the forward path 1? It is from x1 to x2. Here we have taken numbers in the previous example, but यहाँ पे x1, x2, x3 दिया गया है. So you can draw that x1 to x2, x2 to x3 and x3 to x4. So you can write x1, x2, x3, x4 or x5. क्या है यहाँ पे? It is given as g1. Here it is g2, here it is g3 and here it is g4. So path gain लिखना पड़ेगा यहाँ पे. What is path gain? Path gain will denote it as p1. I am denoting it as p1. So it is path gain is a product of all these gains. So it is g1, g2, g3 or g4. Similarly, now I will write, is there any other path? Yes, there is another path. If you see the second path, कौन सा है second path यहाँ पे? You can start at x1, go to x2. From there, see, you can move it like this. That is traveling to x4 directly, then moving to x5. So I'll draw that. See, x1, x2. Sorry. यहाँ से you have to move to x2 से x4 और x4 से x5. ये x5 होगा, ये x1 है, यहाँ पे x2 है. इसकी गेन क्या है? g1. What is the gain in this case? This is g6. So I'll write forward path gain p2 as g1 into g6, and there is another path gain here. This is g4. So it is g4. g1, g6, g4 would be the second path. So let me write the third path. Now path 3. There is another path. If you observe, you can start at x1 and go to x2, and you can directly move on to x5. See, that is from x1 to x2, then directly to x5. So this is x1, x2 and directly to x5. So this is x1 and this is x2. The gain here is g1 and the gain here is g6. So path 3 gain will be g1 into g6. फिर से बताऊंगा आपको. See, Ayush Chauhan, g1, g6, g4 and g1, g2, g3, g5. Exactly correct, Ayush Chauhan. That's absolutely true and very good. Yeah, the number of forward paths are 3. So you have 3 forward paths here. Yeah, g1, g2, g3, g4. That's correct. You should not consider this self path because this is not a forward path. When moving from x1 to x2, x2 to x3, x4, x3 to x4 और x4 से x4 नहीं जा सकते. You cannot move on the same node twice. This cannot be the other forward path. There are no 4 forward paths, there are only 3 forward paths. This is not a forward path because, as I told you, forward path is traversing from first node, input node, to the output node without traversing any node twice. You should not traverse any node twice. Clear? Now this is the second step. What we have done? Forward path. क्या है forward path? Starting at x1 and ending at x5, we are traveling in a path. So there are 3 forward paths: path 1, path 2 and path 3. Now let's move to the next part of this. I'll just take this to the next slide. So we have done number of forward paths. उसके बाद में क्या करना? Let's take a little big. And after completing the number of forward paths, next we need to write what are the third step would be what are the individual loops, और उसके loop gains लिखना पड़ेगा. What are the individual loops? यहाँ पे कौन से हैं? You can move from x2 to x3, then to x2. If you observe, there is a path like this, and we'll draw that. This is x1 to x2 and coming back to x2 again. So ये हुआ x2, ये है x3, ये हुआ g2 पहले से, and this is h1. Now what is the individual loop? You'll call it as loop gain. अभी loop gain लिखना पड़ेगा यहाँ पे. What is the loop gain of that? So loop gain, let us call L1, and this is g2 into h1. Although this minus sign will be given, I'm just neglecting as of now. Just you have to remember that if it is given as minus, you can take it as minus. If it's not given, you can directly write g2 into h1. If it is minus h1, you need to take the minus sign. Alright, and there is another loop here. You can take self loop. You can consider the self loop. Loop is nothing but individual loop. Loop is nothing but it starts and ends at the same node, right? So यहाँ पे एक ही node दो बार आते हैं, unlike your forward path. I have understood signal flow graph, sir. Thank you, SR. So the other one is this one. This is a self loop and its gain is g5. So you can write loop gain L2 as it is on x5 to x4 to x4 directly. So you can write it as g5. So we have written what are the individual loops. And are there any other loops in this? If you observe, now somebody will say that, some students say that from starting from here, moving on to here and coming back to here and moving back here. But if you observe the arrow, it is in this direction. So this cannot be a loop. This is not a loop. Don't take it as a loop. Loop must be a closed path. You should have an arrow. If you observe, now if I take the other one, see, let us see what is the loop that we have taken. Starting from here, moving on to this point and coming back. There is an arrow in the backward direction. This will form a loop. This is a loop. And this cannot be a loop. As I told you, this is not a loop. You should be very much careful. You should be very much careful. So the next one would be finding what are the non-touching loop if there exist. If there are non-touching loops, that we have to see if there are some non-touching loops in this. Now if you observe the loop 1 and loop 2, compare loop 1 and loop 2. Aish Chauhan sir, it's practical application. Generally, these signal flow graphs are used to find the transfer function of a system, and in order to design any system, I'll tell you an example. Once we are done with this, I'll tell you one example. Just remind me. So compare L1 and L2. What are non-touching loops? If there are no common nodes between two loops, we can say that they are non-touching loops. Now if you observe these two, अगर ये first loop को देखो, what is this loop 1? there is x2, x3, x2, and in this you have x4. That means you can say both these loops are non-touching loops. You can say non-touching loops. And you can write non-touching loop gains as L1, L2 is equal to G2, G5 and H1. G2, G5 and H1. With all these information, you can find delta as well. What is delta? Fifth step would be finding delta value. What is delta? Delta is 1 minus sum of loop gains. What is the loop gain L1? It is G2 H1 plus L2 is G5. Okay. Now this is finding delta plus what is delta is equal to? We have seen previously. Delta is equal to, yeah, you can see here, delta is equal to 1 minus sum of loop gains plus sum of gain products of two non-touching loops, then sum of gain products of three non-touching loops. Now if you see, you have only two non-touching loops, so it is L1, L2, it is G2, G5 and H1. So this is delta. Now let us write what is the transfer function. At the end we have come to this. This is 1 by delta sigma pk delta k. Now what is this k? Number of forward paths. कितने forward paths से? 3 forward paths थे हमारे पास. So what can you write? T is equal to 1 by delta p1 delta 1 plus p2 delta 2 plus p3 delta 3 लिखना. Do we know P1? Yes, we know. Do we know P2? Yes, we know. Do we know P3? Yes, we know. Do we know delta? Yes, we know. देखें ना अभी. Just we'll move to the yeah. See, this is P1. I'm sorry. Yeah. So this is P1. G1, G2, G3, G4. This is P2. G1, G4, G6. This is P3. G1, G6. Yes, we know P1, P2, P3. Do we know delta? Yes, we know delta. Delta consists of loop gains as well as non-touching loop gains. So that's the reason we are finding non-touching loops or individual loops or loop gains. So in order to find delta, when we know this delta P1, P2, P3, then we are in need of finding this delta 1, delta 2 and delta 3. What is delta K? It is the delta of the corresponding kth forward path. Karthik, thank you. So delta 1. How do you determine delta 1 is? It is 1 minus. Now you need to consider, you have to be very much careful here. Now you need to consider this path first. Very careful. You must consider this path and check if the loops, see this path has x1, x2, x3, x4, x5, all the nodes. Check if there is any loop which is not touching this path. If you observe the loops, it has x2, x3 and x4. So loop 1 is touching forward path 1 and loop 2 is also touching forward path 1. So in that case, you need to take the values of this as 0. So the delta value will be 1. So it is the delta for that kth forward path. Now delta 2, if you observe, it is the second forward path. It has x1, x2, x4 and x5. Now is there any loop which is not touching this forward path? Now if you observe x2, it is a part of this forward path, x2 is there. Now if you take the other loop, it has x4, and if you go back to this path, it also has x4. That means both the loops are touching this path too. So even the value of that loop gains will be 0 for the second one and the delta 2 value will be 1. Now coming to the third one, यहाँ पे ध्यान से देखना, it has x1, x2 and x5. What does it have? Path 3 has x1, x2 और x5 है यहाँ पे. Now if you compare loop 1 compare करो x2, x3. So x2 is common to this. That means loop 1 is touching this forward path. But if you observe this x4 is not a node in forward path 3. That means this must be considered. That means this second loop is not touching forward path 3. Therefore, the delta value will be, because the first one is touching, so its value will be 0, and the second forward path has a gain of second loop has a gain of g5, so that must be included. So it is 0 plus g5 and the value will be 1 minus g5. Now you know delta 1 value as well, delta 2 and delta 3, all the values you know. You also know delta. You know already what is the value of p1, p2, p3 in the first slide. So you can find the transfer function of a given system, that is x5 by x1. So this is the procedure to find the transfer function of a given system using signal flow graph method. I'll just review what we have done. So I'll just give you in this what we have done in this. In signal flow graph, the first step that we need to do is first identify the paths, forward paths, and write forward path gains. Right, next write what are the individual loops and write loop gains, and find if there are any, identify non-touching loops. If there are non-touching loops, write non-touching loop gain, considering 2 at a time and 3 at a time. Now at the end, find the value of delta, that is 1 minus loop gains L1 plus L2 plus and so on, plus 2 non-touching loops taken at a time, sum of product of 2 non-touching loops and so on. Then from this, comparing these two, whether the individual loop is touching the forward path or not, find delta 1, delta 2, delta 3 values. At the end, substitute this values of delta, delta 1 and forward path gains, will write it as P1, P2 and so on in the expression of Mason's gain formula, that is transfer function T is equal to 1 by delta Pk delta K. So this is a complete procedure of finding. Now let me tell you what is the importance of this. You'll find the transfer function and determine its characteristics. Know the time response or time domain analysis and frequency domain analysis before getting into the design or manufacturing something. Now let us say without knowing its characteristics, I'll just give you one example without wasting much time. Let's say you are given a task of manufacturing a fan, and without prior finding anything and without knowledge of that, there is something that is specified to you that it has to rotate with a speed of 500 rpm, it should consume 1 ampere or 2 amperes of current, and there are some specifications given by the customer. Now what you will do in that case, without doing anything, if you try to design it, and if the fan does not meet the expected outcomes which are given by the consumers, then it would be a waste of energy, time and material and cost, everything. So before doing that, first we'll try to find the transfer function, then we'll try to have the analysis of that. This is not only in case of very small things, it's also very important in very large machineries or manufacturing units. Knowing the prior information and finding it or simulating it, finding the transfer function, knowing its responses and adjusting the values to meet the desired requirements. Yeah, sure, definitely. So this is actually actually semester exams preparation. Probably you'll get to know much more shortcuts in GATE that will be dealt maybe after this short course. Now once this signal flow graph is over, we are entering into chapter 2. Actually this is the chapter 2 part, time response analysis. A time response analysis में हम क्या पढ़ेंगे, we will actually read what is transient response, that is time domain analysis, and steady state response. These are the two things that we'll study, wherein you'll have some of the things like response, first order and second order system, first and second order systems. Also you'll have steady state error and error constants. I'll tell you first what is time response and what is the analysis, and then we'll see what is transient. In that only we'll see what is transient response and steady state response as well. And then we'll come to what is first order and second order system and what is the response to different things. So first let me start with an example. Let me start with this. Yeah, we'll come to that increasing of accuracy once we are doing the chapters as we move on. So let us say you are having some speed of the fan with respect to time. And let me tell you, if you are starting at this point, I'll call this as, let's say you are entering into some classroom or your home at some point of 9:30, and at that instant, let us say the maximum speed of the fan, assume it as 500 rpm, and when you switch it on at this instant, it does not reach this point instantaneously. Rather, it would travel, it would increase its speed slowly as the time progresses. Let's consider zero point 0.1 millisecond, zero point 0.2 millisecond, zero point 0.3 millisecond, and so on. And at some point, does it take much time? It will take very few seconds to reach its maximum speed, and after this it would meet steady point and it will be at 500 rpm till unless and until you change its regulator. Now if does it increase continuously? No, it does not actually, right? So it is a constant to this point, and this period in which it is taking some time to reach its steady state value, this is generally termed as transient response. This is the transient one, and this is a steady state response. So hope this is clear. You'll also come across something like complementary function and particular integral in your mathematics, which is one and same as the transient and steady state responses. All right. So now we'll see. In order to get this response of an any system, you need to have some input, and that input signals are generally termed as test signals. We'll see what are these test signals. We have unit step, it is step signal, unit step input, or ramp input or unit ramp input, parabolic unit parabolic input, impulse signal. So these are the different test signals that we are going to look into. uh, in very short time we'll see that. So now let us consider unit step signal. This resembles a constant or steady input. You'll denote it as u of t, because it being a unit step, you'll take it as constant value steady state at this point 1, and it is u of t is equal to 1 for t greater than or equal to 0, and it is equal to 0 for t less than 0. So if you look at this 0, it is equal to 1 at these points and is equal to 0 for t less than 0. And if you take unit ramp input, so this is how it looks. It resembles a velocity input signal denoted by r of t with respect to time. So it is r of t is equal to t. It is a into t, and we are taking unit ramp, so it is 1 for t greater than or equal to 0 and is equal to 0 for t less than 0. Now, let us consider unit parabolic. It is a sort of acceleration input given to this acceleration signal given to the system. It is something like this, and you can denote it as r of t or p of t, and it is with respect to t and given as is equal to t square by 2 for t greater than or equal to 0, and is 0 for t less than 0. And if you consider unit impulse signal, it is a sudden input that is given at a particular instant. It is available for an instance. Say, let us say we are having this signal at this point, and because it's unit impulse, it is 1 and its area, and delta of t is equal to 1 at a t is equal to 0 and is equal to 0 elsewhere. So these are the standard test signals, we'll call it as. Sometimes in your semester examinations, in most of the question papers that I have seen, there are some questions like what are the standard test signals, explain. So you need to write what is unit step signal. It is a static input that is given to the system. You can also write the Laplace transform to each and everything in your examination, and you can write a unit ramp input. It's a velocity signal that is given to an system. And you can also, Anil Chitluri, good evening Anil. And you can also write unit parabolic, which is an acceleration signal input given to a system. Or you can also write, you can include this unit impulse signal as well. So these are the standard test signals. So these are standard test signals. If you are asked a question on standard test signals, these are the things that you need to write. And also you can write the Laplace transforms as well. Now moving on to, we'll see what is the type and order of a system. So in order to tell you this, first I need to speak of the transfer function T of S. Every transfer function that you see has a numerator and a denominator part. So let us take one example as s plus 1 by s into s plus 3. So there is a numerator and there is a denominator term. So s plus 1 by s into s plus 3. Good evening. So s plus 1 by s into s plus 3. So you have a numerator and denominator. Denominator is generally termed as the characteristic equation. So s into s plus 3 is equal to 0 is the characteristic equation. And here the roots of the numerator are called as the zeros, and roots of the denominator are called as the poles, or the roots of the characteristic equation are called as the poles of the transfer function. Now I have to tell you type and order, right? So what is type of a system? It is the type of the system is number of poles at origin. And what is the order of the system? It is the total number of poles. In simple sense, you can define them like this. What is the type of the system? So type of the system is number of poles at the origin. And what is the order of the system? It is the total number of poles of the given system. So these are type and order of the system. So what is a first order system? First order system is you only have one term in the denominator or only one pole in the denominator. So that is first order system. If you have two poles, it is a second order system. Likewise, if it has three, it is third order and fourth order and so on. Generally will not go beyond these things because it becomes a non-linear system again. So you have understood what is type and order of a system. So type of a system is the number of poles at the origin, and order of a system is the total number of poles present in the given system. So let's consider first order system. Also, order of the system also denotes the number of energy storage elements that are present in the system. Now let me take one example that we have already taken in the previous session. Let us consider a RC circuit. This is R, this is C, this is VI. We are taking output at the capacitor Vout. Now to this I'll draw the equivalent Laplace domain. This is resistance, capacitance, output. So what is the input? Laplace transform Vi of S. Resistance Laplace transform does not change. It is 1 by Cs, and this is V output of S. Now let us find what is Vi of S is equal to. Let us say a current of I of S is flowing through this. It is R into I of S plus 1 by Cs into I of S. And write the output equation. V output of S is equal to 1 by Cs into I of S. Now what is the transfer function of this system? It is V output of S by V input of S. Let us write this V output of S by 1 by Cs into I of S by V input of S is, if you take I of S common, it is R plus 1 by Cs. Let's take this to the next slide. How many energy storage elements are present here? 1. So this is that equation. Now what is V output of S by V input of S? You can simplify this. 1 by Cs by RCS plus 1 by Cs. You can write it as 1 by 1 plus RCS. Generally this RC is termed as time constant tau, that is RC, time constant. Now if you see this, the transfer function V output of S by V input of S is equal to 1 by 1 plus tau into S. So the denominator has only one root if you observe, that is you can also write it as 1 by tau by, that is if you are taking tau common, S plus 1 by tau. You can also denote it as T instead of writing tau all the time. So if you observe the denominator term specifically, if you observe this denominator and you write characteristic equation, so S plus 1 by T is equal to, or tau is equal to 0, S is equal to 1 by T minus 1 by T. So how many number of poles are there? Only one pole. So what is the type of the system here? Type is 0 because there are no poles at the origin, right? So what is the order of the system? It is first order system because it has one pole, right? So V output of S by V input of S is equal to 1 by T by S plus 1 by T. This is an example, or RC series circuit is an example of first order system. To this, if I am applying some input, let us say I am applying unit step input. What is unit step? U of t is equal to 1 steady value. So what is U of s is equal to 1 by s. Laplace transform of 1 by s. Laplace of e power at 1 by s minus a. Laplace of e power minus at 1 by s plus a. Laplace of sin at. Likewise you can write all the expressions, right? So here you will get Laplace of 1. So it is U of s is equal to 1 by s. Now let us substitute this. That is, for unit step input, what is the response of time response? We'll call it as time response of first order system for time response of first order system for step input. So in your examinations also, during your semester examinations, you'll also get some question like Find the time response of the first order system for unit step or unit ramp. I'll tell you one, you can get the rest of the things. Now you can write v output of s. Instead of writing v output of s all the time, I'll just denote this transfer function as c of s by r of s, because c of s is the output and r of s is the input. Now what is r of s? R of s value is, this is the input, r of s is the input. Now I can write c of s is equal to r of s into 1 by t by s plus 1 by t. Right? What is r of s? R of s is 1 by s. So 1 by t by s plus 1 by t. In order to get the time response c of t, you need to apply partial fractions to this. So that is a by s plus b by s plus 1 by t. So in order to find this, you can also find the values of a and b here. Then you can apply the Laplace inverse. I'll tell you there are three things that you need to remember in this to find the Laplace inverse. We'll also do that for the previous one as well, this one. So a by s plus b by s plus 1 by t, a by s plus b by s plus 1 by t. Now this was equal to 1 by t by s into s plus 1 by t. Now if you can also, you can do this by using different methods. Now I'll do it by using one method, as plus a by t plus b by s into s plus 1 by t. Compare the coefficients. So b is equal to coefficient of s. First compare the coefficient of s here. What is the coefficient of s? A. Do you have any coefficient of s in this? No. So a, so b into s. So a plus b into s coefficient. So if you take LCM, b into s and a into, so a plus b is a coefficient of s. If you take, that is equal to 0 because you don't have any s term here, and a by t is equal to 1 by t implies a is equal to 1. If you substitute a is equal to 1, so you can write 1 plus b is equal to 0 or b is equal to minus 1. So these are the values of a and b. So you can write 1 a by s plus b by s plus 1 by t as a is equal to 1 by s plus b is minus 1 by s plus 1 by t. Now if you take Laplace inverse of this, let us take Laplace inverse of this. Now if you take the Laplace inverse to this, so Laplace inverse of, individually I am taking 1 by s is 1 or u of t, and Laplace inverse of 1 by s plus 1 by t is equal to e power minus 1 by t into t, because Laplace of e power at is equal to 1 by s minus a. Laplace of e power minus at is equal to 1 by s plus a. Now here in this case you have 1 by s plus 1 by t, so a should be replaced by 1 by t, that is e power minus 1 by t into t. This is what you'll get it. So what is the Laplace inverse of this total thing? So c of t is equal to 1 minus e power minus t by tau, or t, capital T. So this is the response of first order system, time response of first order system. And if you substitute the values of this, if you consider the values for, let us say t is equal to tau, t is equal to 2 tau, t is equal to 3 tau, t is equal to 4 tau, and so on, you will get the values of c of t. And if you take these values and plot the graph, And if you plot the graph to this, the graph would look something like this. At these 5 time constants, you'll get the value as 0.99. After 5 time constants, you can observe the value of c of t at this. Now let us take first one, t is equal to t. It is equal to t. So probably you'll get as same. So you'll get the value as 0, and if you go on increasing the value, you'll get the value as anything power 0 is 1, 1 minus 1 is 0, you'll get a 0. So at this c of t for time t, the value is 0. As you go on increasing, the c of t will gradually increase, and this is the time response of first order system. We'll see the time response of second order system as well. So today, takeaways from today's class are, we have seen what is signal flow graph technique. In that we have seen what is Mason's gain formula and a problem based on that. Then we have seen what is time response, which is combination of transient and steady state response. And then we have seen what is the type and order of the system, and from that, in that we have also seen what is characteristic equation and what are the roots of the characteristic equation called as poles. Then we have seen what is first order response of a system. So mostly in your question papers you can expect a signal flow graph problem or a technique that is you'll be asked to explain that signal flow graph technique and type and order of a system as a short answer question in some universities question papers. You can also get define transient response and steady state response and find the first order time response of a system. So these are the things that we have discussed, and you can expect one question out of this, 1 or 2 questions in your external question papers. Tomorrow we'll be discussing second order systems. Please join me and get the most out of this, and thank you all for joining me today once again. And we have India's #1 study channels in Unacademy: Creatrix, GATE ECE, EEE and Instrumentation, Unacademy GATE, Unacademy GATE CE, Unacademy GATE Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy GATE Questions, Electrical Junction, Engineering Foundation and Engineering Pathshala. So India's #1 study channels. And if you can like and subscribe, and you can use my code as YSK10 and subscribe karo yahan pe and click this bell icon, and you'll get my lectures, series of lectures. And once again, thank you all for joining me. Hope it was one of the useful sessions for you, so that it will be helpful for your semester examinations. Thank you.